Howdy apes. This is your solar insolation pre-lab. Your purpose for this lab is there on your screen. We are going to be looking at how the angle of the sun influences the amount of energy absorbed by the surface of the earth. We are going to be using a couple of models to represent this technique. You are going to be using pieces of paper at your lab table and a flashlight. The flashlight represents the sun and the paper represents the surface of the earth. Your methods for this will be including protractors. You're going to be using protractors to measure the angle of the sun. You are going to be looking at correspondence with the Earth's angle. You are going to be drawing ellipses. You are going to be using conversion factors, so a little bit of math. And you are going to be using graphing relationships in order to represent your conclusions with a linear regression technique. So a lot of incorporation in this lab here. We're going to be doing a lot, but I really think that this gives a good representation on climate factors and how they are related to solar insolation. So let's get started. All right. First, you are going to need to make a conversion factor. Now, when we do this, you are going to calculate a mass area relationship of a known parameter. So when we do this, you are going to cut a square that is a 10 by 10 centimeter piece of paper. We're just going to use this as our known parameter, and you are going to take the mass of this tomorrow. We're going to use this as our known, and when we do this, this is something that we can take the mass of very easily, and by doing this, we can then use this information in order to make a conversion factor that we can use across the board. So look here on the screen. When we do this, we normally use meters and meters squared when we take masses and use meters squared in our areas as they are related to what we are using for our reference value for the energy per unit area. When we are looking at how much area the reference value for the energy per unit area that strikes the surface of the earth. So when we use this, we actually first need to convert the centimeters to meters. So we first make a conversion factor here. 10 centimeters, which is the length of this one side right here, 10 centimeters, and we need to convert that to meters. So here, 10 centimeters, and we're going to convert that to meters. So 1 meter is equal to 100 centimeters, and here using our dimensional analysis, we are going to cross out the centimeters and say 10 divided by 100 equals 0.1 meter. So now we need to make our meters into meters squared. So 1.1 meters times 0.1 meters equals 0.01 meters squared. All right. So now we have this one area, which was first 10 centimeters by 10 centimeters, is now equal to 0.01 meters squared. This is our known, and now we know how much it is in meters squared. Okay? Hopefully you are with me so far. All right, so now we are going to take the mass of it. Okay? I have not taken the mass of this. I'm going to just guess. Okay. Tomorrow you are going to take the mass of your own 10 by 10 centimeter square. Okay, so you're going to come over here. I guessed, I totally pulled this out of the air, that it was 0.8 grams. So if it were, we would put our 0.8 grams. Oh my goodness.
Ueda, your ride is waiting for you in the front office.
Ueda,
your ride is waiting for you in the front office.
Somebody's ride is waiting for them in the front office. So, all right. So now we will move on. You're going to make this into a conversion factor using mass. So we take the mass of our square, 0.8 grams over our area. Okay, so 0.8 grams over 0.01 meters squared. Okay, because our this is an equivalent now. Okay, we have our mass is equal to our area. Okay, it's the same. So this is now our conversion factor, and we can do it in this fashion with our mass over our area or our area over our mass. It does not matter. You can have it either way. So now we have a conversion factor. You will have to form this tomorrow. So remember, when you get to this point, tomorrow you need to take the mass of your 10 by 10 square and you need to form your conversion factor. There's a place for this in your lab for you to fill in. Okay. So this is how you would fill that in. And remember to do your dimensional analysis if you need to. All right, one more thing to note. The next thing that you are going to be doing in your lab is drawing ellipses. As you are drawing ellipses, you are going to be using a flashlight. All right? When you are doing this, you are going to be using your flashlight as the sun, and you will attach a pencil to it about 8 centimeters out. So you're going to be taping the pencil onto it like this, and you're attaching it like this so that you will use this as a guide, and you're not actually having the flashlight touch your paper at all. Okay? You're going to be using this so that you can use your pencil as a guide on your protractor, and this will be your angle guide so that you can measure your angle as easily as possible. And this will be able to show you what angle you are going to very, very easily. The pencil will touch the paper, and then you will tilt your flashlight down as many degrees as you are measuring. Okay, so this is 90 degrees. Okay, this is 90 degrees. This is straight up and down. And then as you move out, then your degrees get lower and lower and lower, if that makes sense. Okay, so you will not be able to do 0 degrees. All right, you will not be able to lay your flashlight all the way down. It is not possible. So that's the way that it would be at the poles. It's just not possible. So don't try to do that. But it's going to take some work to actually get used to this. Make sure to play around with actually holding on to your pencil and keeping it straight while you're tilting it back and forth so that you get used to that. Okay. As you tilt this, your flashlight is going to be on, and it's going to project a ellipse onto your paper. You are going to measure outside the greatest area of your ellipse. We will turn off all of the classroom lights, and you'll be able to see the ellipse as very, very easily, and you will trace around your ellipse. Then you're going to cut it out, and you're going to do this multiple times. So you're going to have many different shapes and many different sizes of ellipses. It's not going to be very easy to find the areas of these ellipses. It might be very easy to find, say, the area of an ellipse that's like this, but it's not going to be very easy to find the area of an ellipse like this. So just be aware that you're going to have many different shapes. All right. Next. After you get all of your ellipses cut out, you are going to find the mass of the ellipse and use a conversion factor to convert the mass to area. This is how you find your area. This is the easiest way to do that, because we have this conversion factor that you found using your known. All right? You're going to be using the same material. You're just going to be using a different amount of it. So we're going to mass it. You're going to put it on the mass balance and find out how much it actually weighs. So let's say that it weighs 0.3 grams. Okay? You're going to use your conversion factor that you already found out. Okay, remember, this is not what you use. You use your conversion factor that you found. All right? And then you find your area from that using dimensional analysis. Then, after you find your area in meters squared, you calculate the energy per unit area. This is going to be in watts. We're going to assume that your flashlight puts out 100 watts. So you take 100 watts and we say, okay, 100 watts per unit area. This is how much area we have. So 100 watts per unit area, 100 watts divided by the area that we have equals this many watts per meter squared. All right. Then, after you're done with that, you construct a graph. You're going to do these two steps, your mass of your ellipses and your energy per unit area for all of your ellipses. Okay. You're going to have several. So make sure that you do this and fill out your entire data table. Then you're going to have a graph, and this is going to be a linear regression. You are going to construct a graph. Your x-axis is going to be watts per meter squared. So this last calculation that you did right here. Your y-axis is going to be your earth angle. So not another calculation. It's going to be the angle from the earth. Make sure that you heard that correct. If you have a question, feel free to come and see me during lab time. You may not be able to finish this during the class tomorrow, but you can at least get your data down. You also will be responsible for doing a couple of questions tomorrow and then doing a CER to finish out your conclusion. All of this will be due on Monday. So you have several days to finish it all out, but you at least will do your data tomorrow. Okay? That's it. Make sure to read those 3 pages in your book and be ready for your quiz tomorrow as well. I will see you tomorrow.